A new entertainment venue is being proposed. The preliminary design has a constant cross-section as shown in the figure below. The roof height, HW, of the building at any point W along its width is given by this expression just here. H and W are measured in meters. We want to determine the cross-sectional area of the building, and note this is just 2 marks, so this is almost certainly expected to be done just using the CAS. So I'm just going to clear the stuff from the last question. It's a good idea to clear variables, but I didn't mean to hit that button. And so we are going to do an integral, and this integral is going to start at 0 and go to 10 pi. So we'll have 0 up to 10 pi. And then in here, let's stick our integrand in a bracket. So we've got a suitable bracket here. And we have 6 sine, and we'll go for W over 10 in there, so I'm just going to use X, and then just outside here we want plus 3 sine, and it's going to be W over 5, X over 5, and integrate with respect to X, and incorrect number of arguments. I'll just pause and sort that out. I just had a couple of extra brackets in there that I hadn't taken out, so I've sorted that out now, and the answer is 120. So that would be in square meters. So area equals 120 square meters. The designer would like to place a window, as shown in the figure above, that is bounded above by the roof of the building and below by this formula here. With reference to the figure, determine the values of W1 and W2. So let's have a look. What are those? So W1 is the beginning, so that will be the intersection here, and W2 is the end of the window. So what we want to do is find the intersection between this and this, and we're interested in the intersections that are between 0 and 10 pi. So I think we're just going to do a solve. So let's grab that, solve, and we've already got the first expression just here. So let's grab that and bring it in here. And then we've got 7 cos, and that one is going to be x over 20. And we'll solve. It says more solutions may exist. There's a whole raft of solutions here. We could go back here with the solve and ensure that we only get solutions between 0 and 10 pi, or we can scroll across and find them. Remember, 10 pi would be about 31. So we've got a first solution here is at 6.65. So that one is nicely in range. So W1 is 6.65. And then the next one's probably going to be W2, 18.41. These answers should actually be in this section, but don't worry too much about that. And then the next one is 31.41, so that's too big. And then we want to determine the area of the window. So the area of the window is the area of this shaded region here. So we're going to need an integral to do that. And it is going to be the integral from W1 to W2, and we have those values, of h of w take away g of w. So we just need to put that into the calculator, and then we can evaluate that. I'll probably use x instead of w, but I'm going to pause while I do that. You don't need to see me type all of that stuff in. Okay, so you can see I put the integral in. I've got my w1 and w2 values, which I just copied from the line above, and then I copied the rest of the function from up above, and we execute on that. Invalid syntax. I'm going to pause and sort that. Okay, only took a couple of seconds. I just missed the bracket just there after that x over 20. Just got to be careful when you put all these brackets in, and then that should work, and I get 13.94 square meters. So 13.94 square meters. Now for the final part of the question, use calculus techniques to determine the maximum height of the building. So we know this is our function. So I'll just work in the space up here so we can see everything nicely. So h dash to w is going to be, so sine differentiates to cos, and don't forget to use the chain rule. So what comes out of here will be 1 over 10 or 0.1. So we're going to get 0.6 cos w over 10. And then what comes out of that one with the chain rule will be 1/5. So we've got 3 over 5, which is also 0.6. Sine differentiates to negative cos. Sorry, differentiates to cos. So that will be 0.6 cos w over 5. Remember, the arguments don't change, so those are going to stay the same. And we want that to be equal to 0. So we can once again just solve this on the calculator. And in actual fact, we've got our function just here, the 6 sine x over 10 plus 3 cos x over 5. So what I can do here is go to Math 2, do a d dx of that, and I should get the same expression that we have written down for us. So that is that. So it's factorized it, but you can see it's the same as what I've got up here. And then we want to solve that equal to 0. So let's grab a solve, copy all of that, and put it equal to 0. We could give a specified domain, 0 to 10 pi, but we don't need to. We'll just get a lot of answers, and we're just going to go across and find the one that we want. And obviously it needs to be positive. And that one there, the 10, that seems to be between W1 and W2, and the maximum we can see is there. So let's use that one there. So W equals 10.472. Okay, and so the maximum height, all we need to do is substitute back in here and work out h of 10.472. And once again, we can use the CAS to do that quite neatly. So this is my h. Let's just grab it, drag it down to this line here. I'm going to go to math 3, given line, and put x equals, and grab that answer from there and execute, and it says 7.79, and that should be my answer.